In the jeweler problem we started last time on part one, we have a jeweler who uses gold and diamonds in different amounts to make rings and necklaces, selling them for different prices, and our end goal is to figure out how many of each to make as much money as possible. We figured out in part one that we could write equations by looking at how much gold and how many diamonds were used in each of the rings and necklaces and how much we had total of each. We came up with these equations. 5x plus 15y equals 1200. That's an equation for the gold. 5x plus 3y equals 720. That's our equation for diamonds. Now, in graphing, there's a couple of different ways we write equations. One way you've probably seen in math classes before is slope-intercept form, y equals mx plus b, where m is the slope of the line and b is the y-intercept. This is a different way called standard form, ax plus by equals c, and notice those a, b, and c are capital to distinguish from the b in the slope-intercept form. And those a, b, and c are numbers that depend on the problem, and they change the shape of the line. How do we do that? Well, let's start with a graph. And since we know that we're going to be making lots of necklaces and lots of rings, making this graph go about to, 300, 350 on the x-axis, maybe 250 on the y-axis. And if you're graphing this on graph paper at home, I would probably go every line is 10, just like we've done here. That should fit on your paper. So, since we decided in part one that rings, which is a variable, is going to be our x, then the number of rings we make is going to be on our x-axis. Similarly, since we used y for necklaces, we're going to put those on our y-axis going up and down. If we had chosen to do it the other way around, this would be flipped around, but we didn't, so this is what we've got. We're going to remain consistent. So we're going to graph standard form by looking at intercepts. What we do is we say, you know what, let's make all of something, which is the same as saying let's make nothing of something. So in this case, we're going to say let's make all rings, which means we're going to make no necklaces. Since necklaces is y, we're going to let y equal 0. We plug 0 into the equation for y. The 15y disappears. We're left with 5x equals 1200. Divide both sides by 5. X is 240. So we're going to plot a point where 240 x-axis, 0 on the y-axis, right there. Now we're going to do the same thing, but this time instead of making all rings, we're going to make all necklaces, which means the rings is 0, which is x. We plug in 0 for x, the 5x term goes away. We have 15y equals 1200. Divide both sides by 15, we get 80. And that's y, so we're going to plot that 80 on the y-axis, right there. Now, how many points do we need to graph a line? Just 2. We've got 2 points. We connect them with a straight line, and that is our gold equation graph, because that's the equation we've been using. Now we're going to look at doing the same thing, but this time with the diamond equation, we're going to get a different line. The diamond equation is 5x plus 3y equals 720. We're going to make all rings, so the necklaces is 0. We plug in 0 for y. We're left with 5x equals 720. Divide both sides by 5. We get 144 for x, so we're going to plot a point at 144 on the x-axis. That's the blue point. Now we're going to do the same thing, but this time we're going to make all necklaces, no rings. We let x equal 0. Plug in the 0 for x, we get 3y equals 720. Divide by 3, we get 240 for y, so now we plot a point at 240 on the y-axis. As the blue point up there. We got 2 points, we put a ruler on them, we connect them with a straight line. There we go. What we've done now is the red represents the gold, the blue represents the diamonds. We've graphed these, and for now that's where we are, but in part 3 we're going to look at how to go and figure out where those lines intersect and what's important about that. As you graph the farmer problem, you're going to have to graph 3 lines, one for pesticide, one for fertilizer, one for the number of acres. The baker problem also has 3 lines, one for flour, one for sugar, one for time. Toy maker, 3 also, plastic, metal, and time. So we'll be back in part 3 looking at how to find the intersection points of the lines.